If not, please. Okay, can I get a thumbs up on your end just to make sure that you can see my screen? Yes, no? All right, I'm going to start talking. And if nobody corrects me, then I'm just going to talk. So thanks, everyone. My name is Gilberto. I do work for HashiCorp, so disclaimer. I'm a bit biased on my conversation today, but it is a good conversation. So I want to make sure that you know that we take our partners very seriously. Microsoft being a strong partner for us, and so we tend to have very strong conversations about what makes sense for customers, what makes sense for the community. So today, the conversation is about the community.
Oh, and really quick, sorry, Gilberto.
Yes.
We can see your browser, but I'm not sure if you're meant to share slides.
No, I'm not sharing slides. I'm sharing my
Oh,
browser only.
oh, perfect, perfect.
Are
Thank
you
you so
seeing
much.
my picture right now?
Yes, yeah, HashiCorp logo on the left, picture on the right.
That's right. Perfect. So we're
Awesome,
going to move from there. All right.
fantastic.
So what happens next is so what we see in the community today, whenever you do a search for Terraform pipelines in Azure DevOps, Terraform pipelines with Azure DevOps, anything that has to do with a tutorial, whether you do it formally online or you do it on YouTube or you do it in any type of scenario, you see the same message. And it's a good message. It essentially reflects something like this. The idea is you write your code, you purposely build something with the intent to create infrastructure inside of your organization, whether it's cloud, on premises, many clouds, it doesn't matter. The idea is you're going to build something. That something is going to produce some assets, and those assets are called state files, security context, all of those things. And then the idea is that you take that, you create an Azure blob or a blob for your preferred cloud, and you store your asset inside of that cloud, whether that's a state file, your properties, your files, anything that has to do with the deployment that you've had. So that's a good practice, and it works really well for the open source community. And basically, you deliver something into the infrastructure that you're going to see. This is what we see normally in terms of learning the overall structure of the things that we do with pipelines. A couple of things about this. This is not the only way. And the reason I bring that up is because there is a bit of a disconnect in understanding that having the ability to do this doesn't necessarily make it easier in terms of the overhead of management. Because now you have a large collection of Azure blobs or containers, if you will, where your pipeline content starts to reside. And you have to manage that and you have to keep it secure. And there are a couple of things that you have to keep in mind. The first thing that I mentioned is security. That your security posture is utmost the most important thing in your organization. The last thing that you want is for somebody to know that your assets are being deprecated into the cloud and that you're going to lose business because you expose something that you shouldn't. Fine. The examples today focus on this. So we have a small repo here that does some work. The repo essentially has a couple of examples, and the examples kind of talk about what we just discussed, but it kind of just simplify the overall adoption process. So we're just going to show you. That's all we're going to do today. Then we also have slides that we can share with you as a follow-up. And of course, this repo. You can use whatever is here to basically instrument whatever you need. There are 5 pipelines being deployed here. Don't think we have time to deploy them all today, so we're just going to focus on the ones that make sense for this scenario, this conversation. And as we do this, you're going to have questions. So I'm going to try to answer those questions, basically. So let's get started. So I deployed the code to basically instrument the pipelines. By the way, if you're curious about it, this is real code. So the way we do that is we have a large collection of components that essentially deploy. First, we create a project, which is what you saw on the screen just now. Then we deploy and instrument each pipeline individually. And each pipeline is going to have different properties, different purposes, different assets related to it. This here is basically the last thing that I did just a few minutes ago when I was trying to deploy the pipelines and just making sure that everything worked for the demo. If you have the ability to run Terraform code, you can run this pipeline. Essentially, the instructions are here. How you go about doing the work is pretty much just giving permissions for your code to interact with the platform of Azure. That's all it is. And once you do that, you'll end up with a shiny new project, which is this guy right here, which should look familiar to you, which is this thing right here. Okay, so we have a repo, and that repo has content. Oh, we cloned it. Surprise, surprise. And the content here has an extra one, which is the bonus one for this scenario. This is the first scenario. So what we're doing right now is we're basically saying, we're landing in your new environment. We're going to push content to the cloud. And by the way, we're going to create that storage asset inside of cloud so that we can keep our state file. It's a pretty simple scenario that pretty much brings us up to par with that content. So let's go run the pipeline. And while it runs, we'll talk about a couple of things that are happening inside of this deployment. The first thing we're going to do, focus on that, we're going to do a linter test. So if your deployment contains YAMLs, whether it contains JSON, or anything that essentially needs to be tested for context and simplicity and making sure that it aligns with the language requirements, Terraform itself, you should do it here. And this is a good practice. Why do we emphasize this? It's because you can. In Azure DevOps, you have the ability to run tests. In fact, there's a whole factory of tests that you can do against code, against logic. And so you want to make sure that you take advantage of that feature so that you can support it once you run the system. In this scenario, the linter test for us is really just checking to make sure that the Terraform code is valid. And then once we know that the code is valid, then we run a plan. Why do we separate the two? Just practice, making sure that if you run a plan against your code, that it matches the desired effect that you're going to have in your environment. Am I going to have collisions? Is this going to work? Does the resource make sense? Is this logically aligned in a way that makes sense for me? A speculative planning makes sense. Now, once you have that, then what is going to happen is we're going to create a backend. This is that piece that matches this process right here. We're going to create an Azure Blob, and essentially that's going to give us access to the system. So what I'll do right now is I'll just hit refresh here until a fresh animal comes into view. You'll see that here. And that's really the code generating some content in the back end. I'll show you as it builds. It's actually doing it right now. You can actually introspect directly into the code. And once it does it, I think it's just about to finish that. Then we'll have a fresh new animal that is going to give us access to the storage. I think it's called helping shad. So let's go check a look, take a look, make sure the helping shad is available. So we do that. It's going to come in a second. Oh, perfect. So it's right here. There's our helping shad. So Azure DevOps helping shad. Inside of that resource, you'll notice here right now that we're going to create a storage backend. And that's what we're doing in the backend right now. Basically, the pipeline is building all of these resources so that we can build the resources that we need. And so this storage piece is essentially looking to support the ongoing storage for your state file for the Terraform deployment. Typical, and basically it matches the purpose for that particular scenario that we showed you today. So that's the common typical scenario that we see in environments. Inside of this environment, we actually stated things like, let's make sure that we have variables set up properly, make sure that we have versioning enabled, make sure that we have the proper alignment with the account that you want to allow access to. There's a couple of things that you manually have to do to be able to support this. But in the end, you have a proper state. And if I show you that thing, we just call it state. Basically, the deployment that we just did has a Terraform state. And if we download that, it'll just show you that it exists as an object. So I'll download it and see if I can download it quickly. There you go. And if I bring the state, you'll notice that essentially it's a recent deployment for the system. So there it is. So that's my state file. We just downloaded it. It's a brand new one for the deployment that we had. And that's that. So that basically, this pipeline that you see here is now matching the entire sequence that you normally see in the general community examples that you get to examine. Now, why are we showing you this? It's just so that you have a basis for comparison. If you don't have a basis for comparison, then you don't know what to compare to. Now, here's where we go into the improvement part. And we're going to do that in two parts. One, first, we're going to show you how that aligns with Terraform Cloud. And the second one is, well, inside of this pipeline, in fact, when you look into it, pipeline 03, we edit it, and we look at the content that gets included, we had to pass a couple of variables. We had to put in some containers to be able to support this. This is not necessarily a best practice because you don't want to propagate things that could be discovered or could be exposed. And then once you have this, how long do you have, in terms of retention? How do you manage the overall association of those critical elements inside of your environment? These are dangerous things to leave around. Even if you put them into a key vault, then you're going to have key vault proliferation. So we'll talk about how we avoid that in the short term. Okay, so let's go back to that pipeline. Let's complete it. Because this is a demo, we have to basically allow it to expire. So we're going to say, let's go ahead and delete these items that we've created, and let's move on to the next example. All right. We're making sure that we understand there's a balance between what we did here and what we're going to do next. What comes next is rather symbolic. The second thing that we're going to show you is on pipeline, say 5. And on pipeline 5, what we're doing is we're taking this context. We're going to talk to Terraform Cloud, which is where my mouse is hiding right now. And then Terraform Cloud is going to talk to your target environment. In this case, Azure Cloud. It could be anything, of course, but at the same time, we're going to use an element of release to basically take this and release an application based on the proper Azure deployment standards. Why do we separate the two? To ensure that you know that there is build and release context built into the logic for this particular scenario. We don't believe that Terraform is the only tool to do the work. In fact, Terraform can, in fact, deploy applications. The question that you have to ask yourself is this the best tool to deploy that application? And you will have multiple versions of the truth based on your own conditions. But the thought process here is build to the left, release to the right. Build to the left, release to the right. That's it. That's the only context that we want to give you. So let's go ahead and build that. So we're going to go to pipeline 05. And pipeline 05 is going to be very, very beautiful. There it is. And we're going to run that pipeline. You're going to see something parallel in the same sense that we run pipeline 03. We're going to do the QA test. You probably shouldn't see that again, but I think you're seeing it here for consistency. You know that we believe in this when we put it as part of the process. All of you do this in different ways. If you had a test plan from Azure, then you want to tie that directly into your QA process. What you're going to see here, though, is different. You are going to see resources land inside of the Terraform or the Azure environment. Absolutely, you are going to see that. What you're going to see differently is that once we have those resources deployed, we are also going to use Terraform Cloud to host the resources and to dive into the environment. So we're going to show you that next. So let's watch the little lines run. Basically, we just have to wait. This is the part of the program where I do a little dance and essentially just kind of look into your eyes and have an introspective conversation about technology. All of that in a measure of buying time. All right, looks like it's running. I'm wondering if anybody here has any questions while I look at the chat. All right. Looks like no questions. I am absolutely clear on what I'm doing today. So that's great, guys. Thank you. Notice how here, instead of saying create a backend inside of Azure, we're actually looking at creating a Tfc Workspace. And that has a significance because that's going to show up right over here once it gets done. So we'll come back to that in a minute. And then we look at what introspection we did to get to that stage. All right. And as it runs, then now we're going to see. So this is Terraform Cloud. Terraform Cloud comes to you in multiple flavors. You have the ability to run Terraform Cloud in what do you call it? In free mode. Basically, what it means is you can run it with a free account. You have some limits in terms of what you can run, but you can run it on your own. So basically, it's the same as open source, except that it's in the cloud. That's the main difference. It also comes with a couple of measures of protection. So in this case, I'm using dual factor authentication to log in. Here we go. Please close your eyes. Don't remember this number. And basically, once we're able to log in, let me try that again. Terraform Cloud. There we go. 094.096. Hopefully that works. Let me try that again. Okay. 431.782. There you go. Now we're able to log in. Sorry, just a little lag in my phone. And as we log in, there it is. So we just created this. It's called the Azure DevOps Proud Mammoth. This basically, these names come from our random generator. And essentially, one of the things that I want to show you first is we populated the appropriate variables that support this deployment inside of Terraform Cloud. Now, this is sort of contradictory. I just said you shouldn't keep your variables deployed inside of Azure pipelines because you don't want to propagate them. And yet I'm propagating those to Terraform Cloud. So am I a hypocrite? A bit, somewhat. We need those to be able to deploy and talk to your environment. So you don't have to keep them here forever, but you need them to get started. Once you're done with them, you can discard them if you wanted to. It's up to you. These here are being generated dynamically. You don't know that yet because that's part of the next demo. But essentially, that's the meaning behind this particular scenario. Now, we also added some specifics about the environment. Unlike this, you can populate anything from your environment as well. We also automated the run. So right now, this is running and it's trying to build something in the back end. It looks like it's building my Azure resources. So I'm going to go look for Proud Mammoth inside of the ASDO. So let's see. There is Proud Mammoth. Inside of this Proud Mammoth, now we have a service app service plan. And next, we should have the next resource should be an app service container. And through that, we're going to see an application being deployed. So let's give it a moment while it builds. It does take a little while. But basically, this is the overall introspection that I want to show you. All right, so it looks like it's done. So there's a couple of things that we need to do still, and this happens automatically. So here's our app service. Inside of the app service, one of the things we have is we have a deployment center, and this is waiting for an application. Basically, there's nothing there right now. Wait, go back to the example. Oh yeah, it's waiting for the deployment of the application. The separation here is build and then release. Build pipeline, release pipeline, all contained within one particular pipeline. Why do we have this and why is it waiting for? It's waiting for us to approve it. Really, what it needs to happen is we need to have permissions to actually access the Azure environment and deploy directly from this pipeline. The very first time that you need to do this, you need to approve it. So at this stage, at this very moment, you should be generating a service ticket. And that service ticket should be driving a conversation about, yes, I approve the deployment of that application, or you don't. It's completely up to you. And I just did that approval from this perspective, clicking a button inside of Azure DevOps. The truth is, though, that should be automated from a different click. And that click shouldn't be a technical click. As a technical person, I have the authority to do it, to do that inside of an example in real life. The authority should fall under somebody who has the ability to basically manage your budget, manage your projects, maybe a project manager, maybe a manager, maybe a team leader that has the knowledge and understanding of what the implications of that application deployment are going to be. That's it. That's the bottom line. As we see this, at this point, when we go back to our Node.js app, we do a little refresh. I jump around so that we can see refreshes happening. You see now that there's more context and more happening inside of that container that we just created. And we start to see the deployment center take action. So right now it's basically saying, yes, I see a new application being deployed. I have to copy the assets from the source repository all over here and then instantiate the deployment. And this is what is happening right now. So we just have to wait for that to happen. Where is that deployment? Well, that deployment happens to be in our repos. Our repos basically have a breakdown for this. We have the templates, which are basically the templates that we use to illustrate the deployment. The staging components that essentially build the repository. So these build this particular item right here inside of our platform. And they also create the assets we need inside of the Azure platform. And the production app essentially defines how to deploy the resources in terms of infrastructure that you need to support the app. Finally, here's your app, just a zip file. But because of the context of how Azure DevOps does it, it has to go through proper authorization. It has to package all of this and then deliver it to the component. Is this a complex scenario? Not really, not by much. But what we're trying to prove here, and this is the importance of this conversation, is that you can do all of this with a prescriptive method. And that aligns with not just technology alignment, but security. And that really is what makes the change here. So we're going to let this cook. I think it's going to take a little while. But while it cooks, we can jump onto the next scenario. So let me see. I click on different things so we can update the screen. We'll see that happening in a few seconds. So as soon as the screen shows me the app, click on the app and you'll see the app say hello world. We know that it's running. Okay, so there it is. It is being uploaded. It's still not ready. We'll wait a little bit, but essentially that's what's happening right now. Okay, so as it starts to build its settings, we're going to jump into the next example and we'll come back and look at this because this really changes everything. I'm going to point out a couple of things. One, inside of this environment, in Terraform Cloud, we have the context of these variables that are dynamically generated based on the context and the metadata that is derived from the deployment. Hence, we do this with dynamic names. We also have this, your state file. And now that you have your state file, then you start to realize, wait, I don't have to maintain any of that. I don't have to control it. I don't have to worry about having to have the overhead. It just happens here. Whenever you do collaboration, meaning somebody else contributes to your code base, we queue up a new deployment. You decide whether you want to do a full end-to-end deployment, which includes infrastructure plus application, or just the release or what have you. And then you decide how to approve those deployments. And based on a proper CI method, now we can have a second lineage for that state file being delivered here. And that starts to change the overall structure of how you do things. State file is over here. Now we have a clear definition of what we need, outputs, content, all of this is here. This is the bottom line here. This piece right here, this is the end result, if you will, of the thing that we want to see. The app is not ready, so I'm just going to stop that. I'll copy it, load it over here. Once the process in Azure completes, we'll see the app load here, and then we'll just come back and see it. But what I wanted to emphasize is that all of the effort, all of the work that goes into trying to save assets, trying to save variables, trying to locate and secure deployment details in the state file, all of those things, you wipe them off the table. Okay, so let's go back to the last example. We have about 8 minutes before we end this conversation. I want to point out this. This happens to be my deployment of Vault in something we call the HashiCorp Cloud Platform, or HCP. Happens to be part of what I do today. So when I needed an interrupt or a Vault deployment, I just came in and I deployed one based on the things that I needed. I don't have a large deployment. I have a very small deployment done, but I do have a private instance for this that faces my backend cloud environment. And then I have a public instance, which is where I'm showing it right now. Inside of this Vault deployment, I have dynamic Terraform tokens being generated for each deployment that you have so that each deployment is unique. We also have secrets for the conversation that we're having right now so that every time we deploy an application, the secret gets generated. And there's different ways to approach this. For this demo, I just mounted the secrets inside of an environment variable. So these are the things that I'm deploying. If I wanted to be more introspective, I could generate them dynamically, basically do everything that I need to do, sort of like what I do with the certificate generation, and then basically do that dynamically so that every single thing that we do is unique. And this backs up the idea we eat our own dog food in terms of saying that you should authenticate everything, trust nothing, because that really defies the idea that you have to keep static secrets laying around anywhere. And so the proof is in the pudding. So let's go back ahead and do that. So we have one last pipeline. This is the last pipeline that I'm going to show you. There is a significant difference in this pipeline and the way this pipeline runs and the other pipelines, and hence it's not part of my example set. The reason is because this is all built on pure API calls. Pure API calls. There is nothing being used here that is not this is required directly within the Azure DevOps environment. So as I run this is going to do a bunch of work. Each one of those things is going to run in sequence, and as they run, one of the things that you're going to notice is that everything that it gets done is basically a curl call using basic API instrumentation, both against Terraform and against Vault. Okay, and while we do that, I'm just going to show you the code. Let me go back. I'll show you the code. This is the most exciting part for everybody here because code really means that you can do stuff. So let's see, pipeline. I'm looking for a pipeline. I'll do it from this area here. Pipeline 6, pipeline. Okay. On this scenario, what you see here is pipeline 6. So a couple of things. So we're grabbing artifacts, we're grabbing the code, we're taking the code, massaging it, put it into an artifact so we can push it over to the platform. When I meant what I said, and I said what I meant. We're using pure API calls to talk to the platform. So the first thing we do, the first thing we do is we have a response token that essentially talks to Vault and says, give me my secrets. That's the first thing that it's doing. So it does that by basically saying, okay, I want to get my token, my secrets, then I want to get all of the proper secrets from this particular scenario and set them up as secrets inside of this pipeline. If these are static, there's no way you can expose them. And if they're dynamic, it's even better because even if they were exposed, you wouldn't lose anything. And basically, this would be valid for the run. Once we have that, we also do this. Right here, we said, let's go get a token for Terraform Workspace. And we get the Terraform Workspace token. We talk to Vault. Vault talks to Terraform Cloud. Terraform Cloud returns a token. I have an idea. Let me show you that visually so you can take a look at what I mean. Here's what I meant. Azure DevOps talks to Vault. Vault returns secrets. When Vault returns the secrets, the next thing that it will do is say, Vault, that's just Azure DevOps asking, go get me a Terraform token. The Terraform token goes out and gets that and says, hey, I need dynamic credentials for Azure Cloud for this thing to work. Let's get those too. And he gets them. In fact, when we look at the instrumentation, this is really what is happening. We're following a workflow. So it's a small workflow within a workflow. Each one of these sequences can be broken down into concrete steps that are going to essentially give you something that you care about. And the only thing that is being exposed to the pipeline is a role ID and an app ID, which in our nomenclature is a very super duper secure username and password that is dynamically generated with a lot of introspection on randomness so that it's never replicated. And you can put rules around how often you use them. And that generates a token, which gets us to the ability to talk to the API, and that allows us to get secrets. Each one of these things has its own set of content. So depending on what you're doing, you are going to see different sets of steps to support the operation. Okay, so that works, but what happens next? Well, we populate those secrets into a workspace. Whether those secrets stay there, that's completely up to you. We'll note that we use a lot of encryption in our backend to support your secrets. And then once you have that, then we load the artifact, which is the code, the Terraform code that you actually want to deploy. You were there for a reason. And as it runs, basically, it's going to run that plan. So the whole thing that we talked about before, it's going to do some testing. If we are using Terraform policies, we call them really Sentinel policies, but let's pretend they're policies for Terraform code as it deploys into your environment. It's also applicable to secrets. Then you build the infrastructure, and then you go back and you acquire the secrets for the application because you want to load those things inside of the app, and you confirm the identity, and taking a deep breath, build the infrastructure. That's a long way of saying things, but that's what's happening in the back end. And each one of these steps has a different set of conditions that you're going to care about, right? So depending on what you need, that's what we worry about. With 2 minutes, less than a minute left, this is the final application that got deployed a little while ago. This application really is an example of another exercise that we ran through, and it's just a little widget, really. Inside of the Azure pipelines, you should see our pipeline, our latest pipelines being built. Yeah, it's finished right there. And it built the assets and it did the work. Sorry, I'm jumping around too much. I should just look at this pipeline. Yeah, there it is. And it did the job, right? So it finishes doing the work, and it went through all of these steps to finally deliver the effort into your environment. And lastly, this is the last thing that I'm going to show you, is that our assets got deployed. The reason this is deleted, by the way, is because I have a timer in the pipelines. We have a timer in the pipelines, and each one of those pipelines essentially will expire on its own. So pipeline 5, it has a little thing that says, after 10 minutes, go ahead and destroy the infrastructure. It is a demo after all, so whenever we run a demo, we make sure that we clean after ourselves. And while I didn't show you the effort that was done, I show you the end result, which was that application that's deployed here. Okay, to summarize and to end this conversation, there are different ways to run a pipeline. So if you ever run into like, here's the best way to run a pipeline, yes, this is effective and it runs and it works really, really well. However, you also owe it to yourself to think about different ways to approach this with enterprise tools, which makes your lives a lot easier, not just now, but in the future. With that, I'm going to stop sharing and I'm going to answer questions if there is time.
Thank you for that presentation. I don't think we have time for live questions, but if you have a minute and wouldn't mind, Gilberto, if you jump into the YouTube chat, people may be prompted to ask some. I don't think there was any queued up, but thank you very much. Azure DevOps is something I haven't spent a lot of time with myself, so it was neat to see it tie in all those different ways with the IAC pipeline. So,
well, thanks, Jason. Appreciate it.
Problem.
All right.
Yeah.